Hello everyone. Today I talk about the topic for pulse shaping and intersymbol interference. Agenda for introduction: what is pulse shaping? Need for pulse shaping: what is ISI? Effect of ISI? Techniques to reduce ISI? Characteristic: advantages, disadvantages, conclusion. Introduction: what is digital communication? Digital communication involves transmitting data using digital signals. It is used in mobile phones, Wi-Fi, satellite system, and more. Why use pulse shaping? Pulse shaping helps control the signal shape before transmission. It reduces bandwidth usage and improves signal clarity. Need for pulse shaping to reduce interface. Without pulse shaping, signals can overlap and cause confusion at the receiver. This is called intersymbol interference. Pulse shaping helps avoid this. To save bandwidth, it controls the shape of the signal to does not spread to wide in frequency. This helps us use the available bandwidth more efficiently. To improve signal quality, shaped pulses are smoother and easier for the receiver to detect correctly, even in noisy environments. To support faster data rates, with proper shaping, we can send data faster without increasing error. The first diagram for pulse shaping graph diagram. The graph shows how pulse shaping helps control the signal's frequency and power. The blue and red curves represent signals before and after pulse shaping. Pulse shaping smooths the edges of digital pulses, reducing sudden jumps in the waveform. This helps limit the bandwidth, reduce signal overlap. The next diagram for ISI channel input and output. Left side diagram for the top of two boxes show the input pulses. Each pulse has a fixed width. These are ideal short rectangular pulses, easy to send but not smooth. Then right side diagram for after passing through channel. The lower two graphs show how the pulses look at the output after traveling through a real channel. The channel causes the pulse shape to spread or blur. This is due to ISI. Because of this spreading, pulses overlap with the next symbol, making it harder for the receiver to tell whether the signals is ones or zero. What is ISI? Intersymbol interference occurs when one transmitted symbol interferes with subsequent symbol in a digital communication system. This happens because the pulse spread out in the time due to the channel, so they overlap with adjacent. How ISI happens? Channel distortion. Transmission medium may cause certain frequency to attenuate more than other. Multi-propagation. In wireless communication, signals arrive multiple paths with delays. Filtering. Non-ideal pulse shaping at the transmitter or receiver can spread pulse in time. The effects of ISI. Increased bit error rate. Overlapping symbols cause wrong detection of bits. Signal distortion. Pulse shapes are altered. Demodulation becomes difficult. Reduced data rate. Longer symbol duration needed to avoid interference. Increased noise sensitivity. ISI act like self-induced noise, making the system more prone to errors. Complex receiver design. Recurse equalizers are advanced filtering to compensate. Technique to reduce ISI. Pulse shaping purpose for shape transmitter pulses to avoid overlap with adjacent symbols. This method raises the cosine filter. Pulse goes to zero at other symbol sampling points, reduces ISI and limits bandwidth. Equalization. Equalization purpose for compensation for channel distortion. This type's linear equalizer, decision feedback equalizer, corrects the received signal and reduce ISI. Characteristic for pulse shaping controls the bandwidth of the transmitted signal, reduce intersymbol interference by shaping pulse properly, produce smooth transition between the symbol to avoid distortion, satisfies the Nyquist criterion for zero ISI. Intersymbol interference. ISI occurs when one symbol overlaps with the next due to pulse spreading, caused by channel distortion, limited bandwidth, or multipath propagation. Results in signal distortion and higher bit error rate. Acts like self-induced noise, making detection difficult. Advantages: reduces intersymbol interference, improves signal quality, control bandwidth efficiently, decrease bit errors, makes data transmission more reliable. Disadvantages: complex filter design, need precious shaping, may increase system cost and delay, needs more processing power. Imperfect shaping can still cause reduced ISI. Thank you.